Hello everyone, in this video we're going to try to derive a general formula on how to calculate the center of mass for any object with two masses. So in order to do this we will need a coordinate system. So here we will only use one axis because we have only two objects and we can do this with only one axis. We could do this with two or three dimensions too, but this way is much simpler. Say this is the 0 point and we have -1 here, +1, +1, +2, +3, +4, +5, +6. Okay, now we're gonna have an example of two masses in this plane. One mass, for example, one mass is here and another mass is here, a smaller mass. We're going to call this mass M1 and this mass M2. The exact mass of these two are not known. We only know that this one is heavier than that one. Now, there is a center of mass between these two masses. And now we don't know what that center of mass is because we don't know the masses and the distance between them, because we're trying to find a general formula, not a specific answer. And this is not a specific example either. So for example, the center of mass is here. Now we will name the distances from we'll name the distances of all these 3 points. So the distance from the origin of our number line to M1 is called x of 1. The distance from the origin to the center of mass is x of cm. So simple, for center of mass. And the distance from the origin to the second mass is called x2. Now, if you remember from the previous examples, in order for the center of mass to be a true center of mass, the torques on these two objects must be equal. And the torque for each object is the following. Torque for object 1 is equal to the mass of that object times its distance from the center of mass. Now, how do we find the distance from the center of mass given the distances from the origin? Well, it's easy. You take the distance of the center of mass from the origin, which is x of cm, and subtract the distance of the first mass from the center of origin, x1. Subtracting this small distance from this big distance will give you the distance from the center of mass. The torque for the second object will be m2 multiplied by the distance from the second object to the center of mass. Finding this distance is x2 minus x of cm. Now these two torques has to be equal. So we're going to set these equal. m1 times xcm minus x1 is equal to m2 times x2 minus xcm. And the second equation that we used was the equation that shows the distance between these two masses. That distance over here would be, so we need to know this small distance and this big distance, and the addition of those two. Or in fact, we don't even need to know the distance between these two. We will use another equation, and that will be that x2 is equal to, now x of cm, our center of mass, is equal to x2 minus x1. So if we take this big distance and subtract this small distance, if we subtract this bigger distance minus this smaller distance, we will get the distance between these two objects. So this part is actually wrong. And the distance between these two objects can also be written as this distance plus this distance. So x of cm minus x1 plus x2 minus x of cm. And previously we know that this distance is this small distance, and this distance is the distance of the second object from the center of mass. Now we will substitute the value of this term. We will substitute it inside that equation. The value of this term is x2 minus x1 minus x2 minus x of cm. The only thing that I did here is I moved this term on the other side of the equation, and that changed its positive into a negative. Now we have the value of this term, and we will substitute that into our equation. M1 is equal to M1 times x2 minus x1 minus x2 plus x of cm is equal to M2 times x2 minus x of cm. From here on, it's all algebra. So x2 minus x2 is 0. We'll get from here is, we'll multiply the m1 inside. Okay? M1 times x1 is minus m1 x1. M1 times that is plus m1 x of cm is equal to m2 x2 minus m2 x of cm. Now these two terms have the center of mass in them, so that's what we need here, and we'll pull this one to this side, giving us m1 x cm plus m2 x cm is equal to m2 x2 plus m1 x1. We'll take the x of cm as factor, giving us m1 plus m2 is equal to m1 x1 plus m2 x2. Divide both sides by m1 plus m2. All of this cancels with all of that, giving us center of mass is equal to m1 x1 plus m2 x2 all over m1 plus m2. This is the formula that we derived for finding the center of mass of two objects.